So in that context, if you look at it, the idea is that the things cannot be changed, but the transaction fee is charged. So whenever you want to store and retrieve data, for storing the data you have to pay a transaction fee. To retrieving the data you have to pay a transaction fee. So that is what, in fact, one of the paper we have written on trust management in IoT. We have used the blockchain to keep it more secure, to trust the value. But then the point is, of course, on the devices, on the IoT devices, it's very difficult to do that. But then the trust values can be stored and they cannot be changed. They are immutable. So that's something that you can try to look at. So these are some applications. Immutability is one of those aspects. As you see, there are a lot of one change will change the whole blockchain, right? So if you want to really go ahead and manage these things, so you need to download the entire Bitcoin blockchain. In fact, it can be not only Bitcoin, either or anybody. If you want to do this whole process, so you have to look at the incoming transactions and then create a block, find the nonce. That's what I was talking, right? First you find out the transactions, create the Merkle root, then find the nonce, find the new this thing, then broadcast the block, and then if the block is accepted, you get your profit, right? So this is the mining process, which I think must have been discussed. So I'm just going forward. So proof of work is basically the algorithm that is used in Bitcoin. So proof of work is, if you are able to do more work, you can create more blocks. That's the point, right? So if you have increasing hardware speed and varying interest in running nodes over time, your proof of work is determined by a moving average, targeting an average number of blocks per hour. So it is usually 6 to 7 blocks per hour to be created. And if more are getting created, then the difficulty value will change. And then there. So usually it looks at in 2 weeks, about 2016 blocks must be created. If it is created more, then it adjusts itself. So that is what is called a target value, right? So of course, now Ethereum was also discussed, Hyperledger was also discussed. In Ethereum, the proof of stake is being used, right? The consensus algorithm is proof of stake, right? So these are questions that are there, which are there. So some concepts, if you look at it, what were the issues? People started, using powerful resources. Earlier, CPU, and when Satoshi initially proposed, he said if you have one CPU, you get you can get one block to be created, right? So one CPU, one block. So then people said, okay, let us combine more CPUs, right? They created clusters, and then they could do that. They could get more blocks. Slowly, people got more greedy, so they used what is called GPUs, graphical processing units, and then the algorithm in a parallel algorithmic fashion, because mostly go on serial because the number of cores that are there are less. So when you want to find nonces for the next value, there are only one core, or maybe there are 4 cores. So at a time, 4 nonces can be found out, and they can be verified. But just imagine a GPU may have more cores, and more nonces can be found out to verify. At the same time, parallelly, you can try to do that. Or the entire mechanism can be parallelized. So that is what is a GPU that was doing. Later, people came up with GPS also, fully programmable gate arrays, and then later what is called ASIC. Yesterday, somebody was asking a question, application-specific integrated circuit. Yes, you create an integrated circuit which does only one application. It is specific to an application. That application is nothing but your mining algorithm. You take the mining algorithm, hard code that mining algorithm into hardware. Okay, that's where VLSI and some of these concepts do come in, FPGA, reconfigurable computing and all. So what you do is you create a hardware chip for the mining algorithm. You take maybe Ethereum or you take any of those blockchain, and then you create an ASIC for the mining. So what it does, this ASIC is a full computer in itself, but it has only one job, and that is it runs a mining algorithm, and it gives you values. And you use those values and check whether it is correct or not. So that whole process is done using that ASIC. So now, once the ASICs came, people started doing left, right, and center. They started creating blockchains because the Bitcoin mining hardware, highly specialized computers were created. So obviously, the the blockchain community, if you ask, or the distributed ledger community, they started thinking. In fact, people started building coins based on that, and they said, now if somebody can have a very powerful resource, he can take over the blockchain. Yesterday, somebody was asking questions also. Can the blockchain be broken? Yes, maybe in some years. Let us say there's a powerful quantum computer realized, right? And if we are able to code this whole expression as a quantum expression there, you can very easily break the blockchain, right? Provided, of course, you need that huge resource to power that algorithm, which will actually help you solve. Keep on adding more blocks, and maybe if you monopolize all the blocks that are created by you, then basically you can dictate everything in the blockchain, right? Whatever is done on the blockchain, the one with the biggest power. That's what on day one we're going to talk about that also. That 51% attack is basically based on that. So people started working on this. Now the ASIC mining has started. So people looked at. A lot of people started building the ASICs, and then ASIC needs huge computing resource. A lot of electricity is consumed, power is consumed, and hence what happens? A lot of electricity bills are there. So mining pools got together. People got together as pools, put the ASICs together, put the computing power together, electricity together, and then they started creating this. So according to the power that they have contributed, they could get their share of the profit, right? So that's what was done. But what was, people started thinking what can be done, and they came up with new algorithms or new mining mechanisms and new blockchains, in fact, and they have what is called the ASIC resistant mining algorithms. So as you bring in new technology, right, and I was talking about quantum computer being realized, by the time a quantum computer is realized which will implement a mining algorithms and take over the entire the entire power of these, okay, so then you tend to realize that these ASIC resistant mining algorithms will slowly come up, and same thing, quantum resistant mining algorithms will also come up, because there is a mechanism which can resist, right? As you build algorithms which do things faster, you can build mechanisms which delay those things, right? Whatever ASICs could be doing, the ASIC resistant mining algorithms, they resisted whatever an ASIC can do. So ASIC could do something, but then the ASIC resistant mining algorithm needed something which would not, maybe you can create something on reconfigurable computing, looking at the changes that are getting made. So, or each time you try to build a new mining algorithm, a new ASIC or a new quantum computer, and then the algorithm is slightly modified or changed, and then you have to do the whole process again, and then creating hardware is going to be difficult. So the ASIC resistant mining algorithms are developed like the hash coin. So you have the bitcoins, the forking you would have studied. So one of the fork is Hashcash, and then proof of stake is coming up. Of course, now already there. So Ethereum, you can look at it in the Casper. Equihash is there, another ASIC-resistant mining algorithm, and then we will also discuss Monero. Of course, I will not discuss the resistance part, but then RandomX is there, which is adapted by Monero. Monero is another very private, privacy-oriented or confidentiality-oriented blockchain. We'll discuss some concepts. Yesterday, I think Dr. Shivita also mentioned non-interactive, zero knowledge. Some of them are used by Monero as well. So now you may be wondering, where does it stop? How many types of blockchains do I need? Permissionless, permissioned, then public, private. No, sky is the limit. Now, how much you can do, there is a scope. And what are the challenges? I've already mentioned many challenges. Right now, delve into a lot of security, because I've done the introduction and I've revised some part of the blockchain for you. Now we will start this aspect of this. So these chains have come up. I think now it's 1 year old. Beacon chain has come. Shard chains have come up. Of course, somebody who discussed Ethereum would have mentioned these to you, right? So proof of stake is proof of work is the power that you have. Proof of stake is how many bitcoins or how many coins, how much of cryptocurrency you have, or for how long you have kept the cryptocurrency, how interested you are in the blockchain to be successful, right? Then you will be given an advantage, right? So for people who don't have a stake, their what do you say, mining algorithms will run slow. So I don't know how they have done it, but then that's how it is. So because you would want a honest behavior, so that is what is called. So now we actually come to the security aspect. So what attacks can happen on a blockchain? So one of the important attacks that you can look at is the double spending attack. Right? A double spending attack is not possible, but unfortunately, some seller is very very proactive before the transactions are confirmed. If he wants to give away his product, and mostly the products are delivered if it's a hard copy book, or maybe it's a big item, or it's a mobile phone. It may take some time, but if it is maybe a software license, maybe a software download, or maybe you're downloading an ebook, and you give the link to download the ebook. Then once the person has downloaded and you say no, the blockchain did not work, please send me back that this thing. You cannot. So here is a simple example, right? There are few individuals, they are there, and there's Gillen who is making a transaction to Nadir, and there's another person, Brian. Both are because Gillen is making a transaction. So, but then the point is, he or she can use the same Bitcoin. One Bitcoin she has, maybe the one Bitcoin she is giving to Nadir, and one Bitcoin or maybe 10 Bitcoins. She is giving the same Bitcoin, 10 Bitcoins to Brian, and same 10 Bitcoins to Nadir. She has only 10, but she is giving 10 to Nadir also and 10 to Brian also. Both are able to get. So what is there? Gillen is trying to provide this thing, right? So what is the reason for success is buyer sends the same coin to two different vendors. Let us say Brian and the other individual Nadir are two vendors. Both vendors get the same 10 bitcoins, and but Gillen has only 10 bitcoins. So if two blocks, each with one of these conflicted transactions, are mined at the same time, these two transactions are going, the two transactions can go into the same block. If it goes to the same block, it can be very easily verified. Instead, they are coming from the same individual. He has only 10 bitcoins, and only 10 bitcoins are to be given, but here there are two transactions. How can I make these two transactions? Not possible. They will be discarded. But fortunately, let us say there are two people who are picking up on the mempool. All these transactions are lying. One fellow has taken 10, and the other fellow has taken 10. Each of the transactions have gone into a different block. Both the blocks are mined, right? If both the blocks are mined at the same approximate time, right, and the seller B, he sees that seller A gets the Bitcoin, seller B gets the Bitcoin, but seller B, before he ensures that this transaction got through successfully and completed it, because what you need for a block to be confirmed, it would have been good if it was an interactive session, but anyway, as you're all muted, the answer is we have to wait for the confirmations. At least 6 or 7 confirmations should come before a block the block and everything can be added, and I can look like how my transaction is done, but I may get that information, but till the 7 or 8 confirmations are received, I don't have to consider that this block is done or this transaction is done. But maybe seller B is active and he says, "Chalo bhai, ho gaya transaction. Let us pay this thing." So he sends out a software or maybe the online book or something, and he sends it out, right? So later he realizes the transaction is rejected. Then there is no way, because if one block gets accepted with that transaction, the other block is supposed to fail because the transaction is not a correct transaction. So these are issues which come. So many times when these double spending attack happens, right, and fortunately it is a trial and error, right? So if both the transactions go into the same block, one of the transaction will get discarded. If both go into two different blocks and they go ahead, and after some time one block gets failed and one block gets passed. So that's the diagram that you can look at it. It's something like this, right? The transaction which gets the maximum number of confirmations from the network will be included in the blockchain. So what has happened? Seller B gets a transaction, but this transaction is not going ahead because there is one wrong transaction here, because this transaction has been successful. The 10 bitcoins that Gillen had are spent. The other 10 bitcoins which are going to Nadir are not available. Hence, the transaction is not validated. When the transaction is not validated, this block is abandoned. When this block is abandoned, this is rejected, because here, if you get 6 confirmations, as more and more blocks get added, it receives more and more confirmations. And as it receives more and more confirmations, more and more blocks get added, the blockchain grows. As the blockchain grows, that becomes the official blockchain. And this block, which also added as another false transaction, that block gets dropped. And once the block gets dropped, right, all these transactions are reversed. Sometimes these things happen and they move forward. And here also some transactions are there and they move forward, but these transactions are maybe few transactions are not correct, like the double spending transaction has happened here. The remaining transactions also sent back to the pool. Similarly, Gillen's transaction also comes back, and Gillen's transaction is verified again. And when you see the transaction, Gillen doesn't have, because by that time this block is added, because this block is added for who is that person? Brian. So Nadir's transaction is nullified here. It comes back, and when you check, Gillen doesn't have more 10 bitcoins to give. She has no bitcoins, but she's wanting to do 10 bitcoins to Nadir, which is not possible, right? But Brian has successfully got it, and then this proceeds, and this is accepted. So these are the successful, what is there? The seller B must be careful to avoid double spending, right? Buyer succeeds in double spending by confirmed transaction to seller A and rejected transaction to seller B, but receives the services from transaction seller B. Seller B's problem or vendor B's problem, right? So he has to be careful. But then the next we talked about is the 51% attack on this thing. 51% attack is when a single miner or a group of miners attains majority of the network's hash rate. So in that case, what happens? They prevent transactions and blocks from being verified. You cannot, you can, a group of friends are there. So all of them are there. They know who is adding the block. So obviously they will all verify it. So the majority of people, if they are belonging to, they are your friends, you can actually form a syndicate. But fortunately till now, in the blockchain, this is not possible. But whenever this is possible, you get what is called a hard fork, right? So blockchain splits because people claim this is also correct, people claim this is also correct. Both the chains are said to be correct. After that, both chains proceed for a long distance. Then they have to sit down and reconcile. Somebody has done something wrong, but then both the chains have grown to a long distance. Now you can't dump both the chains. So the new chain or a chain which is, they have to agree and compromise that, okay, let us continue further, no problem. And they have both these things. So some part of the chain is common, and from there is a split, and then there are multiple chains that are there. So this is what happens. Right? This is the 51% attack. So what happens when the majority share takes over? Now, this can happen when huge sources are available with one particular group of miners. So as they get more and more rich, and they invest more and more money into resources and computing and power supply and all that, so they get majority of the network hash rate. Just imagine somebody was working with the Bitcoin mechanism, right? A huge power was there at his disposal. Suddenly he says, "Now what ho gaya? Let me do somewhere else." So he goes to Dogecoin or something. It's a very small network, right? And then he can use all his resources and take over the network. Kind of easy. But then still, even then, it is really not possible, because there are so many people in the whole world, and you can't stop any of them, because they're very decentralized. It is distributed, right? So there is no centralized this thing. There is no way to estimate how many people will get involved. So any number can get involved. Anybody can do anything. So that's where the whole aspect goes on. So you can't prevent the transactions. You can't have the blocks from being verified. You can reverse the transactions to allow double spending. So you can some transactions are coming back saying that these are not valid, but then again you can again add it to another block and send it, and finally they can get adjusted because other miners will approve the transaction. So maybe the money is not received, but the transactions are approved. Prevent other miners from finding any block, and then you can also fork the blockchain. So once you have that 51% of the power, more than 51% of the power, more than half of the power, that's the basic idea. And it's very difficult in that sense, but then it's not impossible, right? It's not impossible to create a huge resource. As more and more pools join together to form a bigger pool, it's not difficult to defeat the remaining people, right? It can happen when there is a centralization by many pools which acquire more than 50% of the hash power. It is easy to implement in altcoins, smaller coins, it's easy to take over. In order to control 51% of an altcoin's hash rate, only a small proportion of the miners from larger coins to needs to switch to a smaller coin, as I discussed. From Bitcoin, if you want to come to Dogecoin or some Lakshmi coin or some of these coins, very easy to do that, right? Very difficult for blockchains like Bitcoin and Ethereum because there's so many people interested. The cost is also more, and hence it is difficult, but it gets much cheaper quickly for your blockchains. So you will need about $1.5 million to execute a 51% attack on Ethereum Classic, which is having a market cap of $2 million. So almost 1 million and 2 million. Yeah, right. So that's almost maybe 100 times. So that's the kind of resource that you need. But as the whole world over, people are competing and they are putting their resource into it. So as of now, this is getting if I get those resources, I can very easily take over that. Three times in August 2020, right? So attack can be identified by unusual conflict.
जिसका आधार में खड़ में थी जिंदी थी वो आराम से कोट कर निकल ले ऐसा था
जाओ लो देखो क्या होता है तब बताना हमको
They have a mechanism called chain locks, right? So what happens? It prevents block reorganization by making it expensive for the attacker. So there are these variations also are what differentiates and separates different blockchains. So that's where for specific reasons you can create different blockchains, right? As Monero we discuss in some time, we will see that it requires it handles confidentiality and privacy, so that's what is there. So that's 51% right. Dr. Sushmita made a passing remark to what is called is selfish mining attack, right? What is selfish mining? Selfish mining is this block is created, block 2 is created, and after block n is created. Different miners who are looking at block n plus 1, and is one miner, miner A, let us say, he has got block n plus 1. What he should do? He should announce to everybody that I have created block n plus 1. But because he is selfish, he is a selfish miner, what he does, he doesn't announce. So there are other individuals who are still struggling, and finally they get block n plus 1. Meanwhile, what this fellow is doing is not announced block n plus 1, but he started searching for block n plus 2. By the time some transactions have come, he picked up some transactions, identified that these transactions I am taking for the new block, and he is trying to add it to a new block and then creating a new block, finding the new Merkle tree, finding the new nonce, finding the less than the target value, adding a block. Blocks are added. He is not still announcing. What he is doing? He is announcing the third block. He is looking for the third block. Suddenly, multiple blocks are added. Here, by this time, n plus 1 is added, n plus 2 is getting added, this fellow is added, n plus 3 also. And after that, he announces all the 3 blocks in the same time. You would have seen some blocks, right, which are created in 1 minute duration, right? What are they? They are actually these blocks. This block was created, then this block was created, this block was not announced. But later, 3 blocks were suddenly announced. In the duration of 3 minutes, 3 blocks are added one by one in the same blockchain. So what has happened? Two sets of sequence. There are 3 blocks on one side and there's 1 block on one side. The second block is getting added. By the second block is getting added, by the third block has already been added here. So others will come and give more confirmations here. And when they give more confirmation here, this selfish chain becomes the actual chain. And this chain gets, the honest chain gets dumped. This is the kind of process that people are having. So why should I announce immediately? Let me build a blockchain of 4 or 5 blocks, and at the same time I get all the 4 or 5 blocks money in one go. That is what is called a selfish mining. Now just imagine how much of programming, how much of algorithmic thought process, how much of resource management has to be in place to ensure that you should take a risk like that. So you earn 4 blocks instead of 1 block in no time. By just making a small change in the usual mechanism. Honest mining, and this is dishonest mining, right? So that's what they deliberately keep their blocks private as they discover. They continue to mine their own private blocks, and they create a chain longer than the usual public blockchain. They sell it suddenly, they realize the private blocks, and then they get all the blocks are added. So all the blocks they get, and they get a higher reward, right? And these honest miners are doing those, and they lose that money. So there was a distributed denial of service attack. Wherever there is a resource, people can keep attacking. So DDoS, you have seen in multiple ways where a system becomes unavailable, right? So availability attack, DDoS is an attack on availability. So here we see that you can have DDoS attack on the distributed network also. But multiple distributed DDoS attacks were launched on competing miners. So you are doing mining process, but you don't want others to win, right? Maybe the 3 idiots formula, right? You work hard, but you disturb others. One is all of them are working hard. Whoever works hard will get the best. But one is working hard, but disturbing the others. So what happens when the others get disturbed, you tend to do it faster. So others are put to DDoS attack, and you are actually doing mining, and you are successful. Because they are running programs, and their programs are, their systems are shut down, reset, and network is down. All of these things happen, and there is a lot of problem. Hence, you launch them on competing miners. You take them off the network, and then you get a more bigger share of the miners' hash rate. Similarly, honest miners, you put some transactions which are actually waste transactions, right? So fake transactions you put. And then you are doing you know what the fake transactions are, so you don't do the transactions because there is no transaction money there. You take the actual transactions which are not fake, and then because you know them, you identify, and then you reduce the chance, you reduce their chance of mining. So that is a DDoS attack. So now this is slightly beyond blockchain. What happens? There is a DNS network, right? So DNS server is there. So what you do is you isolate a user from the real network and lead them to a fake network, which is actually not the blockchain network. You are a Bitcoin node, what is called Bitcoin core. You have set up a node. The Bitcoin node setting up software is called Bitcoin core. So that software, when you set up, you become a node. So this node gets connected to the blockchain by going to a DNS. But then if you attack the DNS, the domain name server, right? The domain name system server, DNS server. If it is compromised, I say I want to go to the blockchain, and the DNS replies, go to this blockchain. This is the blockchain. But I want to actually go to the actual blockchain. I am sent to a fake blockchain, and I start making the transactions there, right? So that is what actually happens. So this is the actual blockchain network. I should go here, the DNS server should direct me here. But what is a DNS server doing? The user wants to go to the blockchain. But this attacks has DNS cache has been poisoned. So when I go here and ask for an address, this cache poisoning will return a new address. This is a different address, this is a different address. So the address that is returned is a different address. And when you use that address, you go to a different network. It looks like a blockchain, like a phishing attack. You want to go to bank, this thing, but it is actually taking you to some fake website, right? So these are some of the things that happen at the network level, right? So the fake entry point nodes return to the user routed to the alternate network rather than the current blockchain. So at the DNS network level, you can do cache poisoning, and then you can do that. Then there are eclipse attacks. There are a group of malicious nodes isolate its neighboring node and compromising their incoming and outgoing traffic. And they change the blockchain view of the honest node, right? So there are a lot of nodes which are there, and then they make up the distributed network. And when you want to actually interact, so a group of malicious nodes, some of the nodes which set up the Bitcoin core, so if they want to act malicious, they can create a network. It's something like your wireless sensor network nodes. Similarly, you can have here a network nodes which are having, so they can compromise their incoming and outgoing traffic, and they change the blockchain view. So feed them with fake information regarding the blockchain transactions, and then they are there. So all these white ones are the safe nodes, but all the pink ones are there. So what happens? The white nodes are honest nodes which are attacked by the red malicious nodes. So they are, and slowly as the white nodes are attacked by the malicious nodes, they also become the malicious nodes, right? The malicious nodes then send fake transactions and block to these nodes. The white honest nodes attacked by red malicious nodes, they are also becoming the malicious nodes. Coming to the privacy attack, as we look at, blockchain is considered anonymous because the user is identified by its address only and can generate as many alias addresses as possible. Right? You can create multiple alias addresses. In fact, in virtual machines also, once you create a virtual machine, you can create multiple alias addresses, right? Because the hypervisor knows the address and you can try to create. In a similar sense, in blockchain, you can create multiple public addresses, right, out of that. So you can actually hide yourself. You can have multiple public addresses, and then you can generate as many addresses as possible. They will point to the same wallet, but you can have multiple addresses, right? So a blockchain is replicated at each node. As we know, the observer can use the transaction history in the blockchain to find the topology of the network. So this is what I was talking about, right? When Bitcoin core nodes are set up, and they're all different nodes are set up from different points. So blockchain keeps track of how many physical nodes are there. They can come from an exchange also, but the exchange aspect is different. So exchange is connecting. So the exchange has more wallets. They are all maintained. So that's where the role of the exchange comes. When you create an account with the exchange, your private key is not with you. Your private key is with the exchange. So that's a solid disadvantage. And that's where the eKYC and all the transactions that you do are open to the wallet and open to the government for scrutiny. So you can use the exchange, you can trust on them, because again there is no centralized agency. Suddenly one day the blockchain is closed, there's nobody who can help you. So that's the question. So here, as you look at it, the topology of the network can be created, because whenever a node is created, the node has an address, and you can easily track that address and find out. So that's something that you can try to look at. You can get the topology of the network, right? And then you can get the patterns of the transactions. As I told you, all the transactions are there, and then you can try to get to the network node where they are connecting from. You can get to their IP addresses to a large extent, and then you can look at all the transactions that they're doing. You can do all the user interactions that it is doing. So all these things are taken place, and then you can try to do that, right? So that's something that you can do, right? So I just take a small break here, and then we'll continue in about 5 minutes, right? I just stop here. Then maybe before I start, we have a lot of questions to be addressed. So I will answer the questions and then start forward. Just we'll take a 5-minute break.
Recording stopped.
Just wanted to know if, because it is already 11, are you going to answer some questions which are there on the chat box?
I'm I'm just taking some water break. I'll answer some questions, then we'll take a break. Right?
Okay, fine. Yeah.
Just give me 5 minutes.
Thank you.
If blockchain has vulnerability, then I can attack on it, right, sir? Yeah. When you look at the variety of users of blockchain, am I audible?
Yes, sir.
Yeah. So the first question is, if a blockchain has vulnerability, then I can attack on it, sir. Yes. As the blockchain builders, there is very rare chance that there is a vulnerability. But now we have a lot of scripts. Next session, I'm going to talk about some scripts that you can use. Ethereum smart contracts you would have been introduced, right? So there are some HTLC scripts and all that I will shortly explain. So those scripts can have vulnerabilities. Your solidity, in fact, I was about to some of the maybe I will continue that lecture where I stopped. Right? So solidity has a lot of these aspects as well. Vulnerabilities as well. So programming languages which are used or the environments in which these things are used, they may have a vulnerability, and those issues can be attacked. So obviously, smart contracts may have vulnerabilities, solidity codes may have vulnerabilities. The blockchains, new blockchains that are getting created, they may have vulnerabilities, and they can be attacked. So that's one level. But of course, as you look at it, it is more and more difficult to do those things, right? So that's the what is the Bitcoin current hash rate? Miners are people who add blocks that I explained. Maybe you asked the question earlier. Hash rate means the power. The hash rate is the power that you need to create those hashes. So how many hashes you can create? When you talk about 180 million hashes per second, so in 1 second you must be able to calculate that many hashes. So that's where huge power is required, right? And those hashes that are generated, 180 million hashes are generated in 1 second, and they are verified with that block, and then a block can be added. So you just imagine in 10 minutes, so many block hashes are generated, and they are all verified whether it satisfies the difficulty level or not. And if it is yes, then the block is added. So that's the rate that we are talking about. It almost touched 200 million this thing also. What is the need of solving encryption algorithm during mining? Is it only for making mining difficult? Can software algorithm solve itself to mine Bitcoin? Yeah. So the mining algorithm has to be implemented in the software, and the software should give the result of the new hash, and the new hash must be less than the target value. So once you get that, then the block can be added. So the whole point is the mining program or the ASIC that I talked about, the hardware component that you create, it finds out that nonce value or the new hash value. And once the new hash value is identified, and then the block is accepted. So there are no self-mining software which can mine themselves. Hardware is created, ASIC is created to solve a mining algorithm, but there is no software which solves the mining algorithm itself. Of course, the mining algorithms are implemented into software and they are run. The input is, as I mentioned, those three values. Previous hash value, the Merkle root, and the nonce value. The output is the new hash value. The new hash value must be less than the target value. If that is satisfied, that's what is the algorithm. Can you please share an example of transaction mentioned in this slide? I've shown the transaction, and now in the next lecture when we talk about scripting, and we also talk about atomic swap, an interesting concept, I will mention that. High consumption of electricity and emission of CO2 may be severe impact. Yes, definitely. If there is no miner, how the next block will be added to the network? Yes. If there are no miners, no blocks can be added. If there is no transaction fee, there will be no miners. So these are the issues. Banks exist because people are going to the bank, storing their money, taking loans, paying interest. So all these things are happening. So that's why banks are surviving. And you are asking a question, what happens if no banks are there? You can't think of life like that, right? In a similar thing, miners will be there as long as there is money involved and you want to exchange the money and make transactions. People will need to do
मेरा कौन
transactions, right? You want to
आके
buy
वैक्सीन
something and you want to sell
कह रहा है,
something,
समझा?
and
कोवैक्सीन दे रहा है
blockchain
कि
or Bitcoin
कोविडशील्ड
may be a
दे रहा
mechanism where
है।
you want to hide your money and your resources.
हम
So
हमसे
as
पूछ
long
रहे
as
थे
such
मैं
kinds
कोई
of needs are there, as long as you want to buy things which you won't want public to know, and then you
जो
still want to do it,
भारतीय
so
लेगा
you
सो
will
लेगा
find
कि
a mechanism how to do
विदेश
it.
में ना सो
So
लेगा।
those are
बता।
things that are there, right?
अब
And
वो तुमको
this is
तो
going
नहीं
to
पता
really
हम
affect
कौन है भारतीय।
our natural
वो तुमको
resources.
अंग्रेजी
A
पूछना
huge
पड़ेगा।
power means a lot of water will get used, a lot of coal will get used, a lot of CO2
अंकल
emission
जी
will be
से
there, and that's all.
अरे
What is
अंकल जी
inside
जाके
Bitcoin
कुछ हो नहीं रहा है जब
transactions?
बात कर रहे हैं।
Bitcoin transaction is where I want to send. It's like a financial transaction on your bank account. You have some money with you. You want to give somebody else. That's a transaction. Of course, you can use data also as part of the transaction. You can store a trust value. You can store some secret code or something. That can also become part of the transaction. Any data can be part of the transaction, but to store the data on the blockchain, you will have to pay a transaction fee. In selfish miner chain, are the blocks or more can be created simultaneously or one after the other. One after the other, then you are not disclosing, and hence suddenly you disclose after some time. Not 3, maybe you create 5 and you disclose. So there are 2 chains which are formed. One chain has only 2, the other chain has 5. So the 5 chain will get finally accepted by others. That's
आज
usually
आज
the normal case, right? How can we prevent DDoS attacks are help in crash the website? Yeah, blockchain is also kind of a portal, kind of a website. You can think because data is stored, and attackers, if you know who the attacker, who the miners are, you can attack the miners attack, miners network. So if you know where the miners are connecting from, and you stop their network, you disconnect them from the blockchain network, right? Then you are there only. Others are all dropped out, right? 3-4 attackers there, their network is down, their internet is down, right? And then only you are there. So that's what we talk about DDoS, right? Yeah, selfish mining I have repeated, right? How can we attack on it with killer? Okay, what is nonce? Nonce is a value which can be incremented, right? So that andersworthbrown.com/blockchain website that I suggested, you please visit. Then you will understand what is the value of a nonce. Nonce is the value that is calculated. So when you want to find out the actual hash value which determines this thing, so you calculate with a nonce 1. It is not satisfying. A hash value is calculated, but hash value is not less than the target value. You increment nonce to 2, nonce becomes 3, nonce becomes 4. You can increment it sequentially. You can increment it randomly. Either way, it has to satisfy the proof of work algorithm and result in a hash value. That hash value must be less than a target value. Target value will have some preceding zeros, 19 zeros, sometimes 20 or sometimes 18, but usually 19 zeros. So that hash value has to come. So hash value which starts with 19 preceding 0, very difficult to obtain, right? So that is something that is important, right? I think I have gone down, up and down, right? Will a developer have to write a program to find the nonce? Yes, that is what is the mining code that is there. Mining algorithm, when it is implemented, it finds the nonce. Bitcoin created where to invest? Yeah, bitcoins can be created when you add a block. You are gifted, you are rewarded 6 bitcoins, 6.25 bitcoins as of now. Where to invest? You can sell it and you can get Indian rupees, and then you can do it, right? How Mount Gox lost so many bitcoins in 2014 because somebody attacked them and they stored the addresses. Okay, the private keys, if they are stolen, they can make a transaction on your behalf because your public address is known to everybody. Your private address is not known. That is the key. If the key is stolen from you, right? It is like your email. Anybody can access your email when they know your password. They may not know your password. Your email is known. Your email ID is known to everybody. I can keep trying different email passwords, and if I am successful, that is the same thing what happened with Mt. Gox. Mt. Gox lost all its data, and you cannot get it back because once the address is available, you would have transferred the money to some other account, and you can't trace it as well, right? So I'm very much confused with such high. Yeah.
Professor Pilli,
Yes.
We can have a small break and you can continue with the questions because I know that there are so many questions.
Yes.
You need to have a break. You have been speaking for 2 hours now.
Right.
So
Sure.
we can have
Yeah,
a
usi
small
jagah
break
bolo.
and then you can continue with
Okay,
at
okay.
11:30.
11.
Have a good tea or coffee. I wish I could share with you.
No problem. Yeah.
Okay.
So we will start at 11:30.
11:30.
Yeah. And first I'll take the
1,
questions.
yeah.
Then I'll take. So I'll go on
Yeah.
till 1 o'clock, right, ma'am?
1 o'clock. So you can finish by 12:30 so that you can answer questions to.
Sure.
Okay. Thank you. Thank you so very much. Such an interesting session you have made it.
Thank you.
Thank you.